Happy Friday, TGIF. And weekend's already here. I think we have two problems left to look at, right? So we discussed what a unit vector and direction vector was. Right, so we have to find a unit vector in the direction of this vector. Right. So since the direction is not changing, there's only one operation that we've studied that does not change a vector's direction, and that's scalar multiplication. Right? Multiplied by a positive scalar, all you're doing is adjusting the length, not the direction. If you multiply by a negative scalar, the direction just flips 180. Right? So it just goes in the exact opposite direction, and possibly then the length would change. So we have to, so what we're going to be doing is multiplying v by some scalar such that the result is unit length. Well, then once you just multiply by 1 over its length, and then the result would be unit, right? That was proved in the video. So first, find the length of v. And I'm going to say the unit vector is represented as E sub v. Right, that's standard. Right, 1 over the magnitude of v times v. Right, magnitude, remember, square root, sum of the squares. So 1, right, plus 2 squared, plus 2 squared. And then times our vector. One, 4, 4, that gives you 9, right? Root 9 is 3, so it's going to be a third times our vector. That makes our unit vector 1/3, negative 2/3, and 2/3. And again, this is also a direction vector for v. Said the idea of direction vectors will be important when we study multivariate derivatives. Of course, this wouldn't be a calculus class without some physics. Weight of 100 pounds suspended from two chains, making angles with the vertical of theta and phi shown below. We want to find the magnitude of the force applied to each chain if both theta and phi are 60 degrees. In other words, we're finding the tension on each chain. since both angles are measuring the exact same, the tensions are also going to be the same. Right? Magnitude of the tensions are going to be the same. Right? Obviously, they're going to be different directions. But since we're looking for magnitude, that's fine. So all we have to do is actually pick one and find the tension on that chain, and the magnitude of the tension on the other is going to be identical. So without loss of generality, we're going to look at the one on the right. So we're going to consider theta. We know it's 60 degrees. Which means that angle has to be what? 30. What's that angle? Why is that important? Because we want the angle with respect to the positive x-axis. So that chain makes an angle of 30 degrees with respect to the positive x-axis. Is that what I want? That's not what I did. I think I'm wrong on what I did. Yes, I am. So we draw a force diagram. What we do is we just assume that the object in question is a point mass. And then we examine the forces on that point. Right? Essentially, we're doing an analysis on the center of mass. Let's call that tension 1. Ignoring the second chain, how many other forces are acting on our point mass? What is it? 1. What's the other force? Which is always straight down. Call that F sub G. Okay, so this is where I'm going to introduce new notation. It's common notation. To represent magnitude of a single vector, we just remove the arrow over it. All right, so instead of writing the double absolute value and then the vector inside, we'll just remove the arrow. Typing it up in text, you just remove the bold. Right, you write it as a italicized letter instead of a bold-faced letter. What's the magnitude of the force due to gravity? 100 pounds. Remember, weight is a force. It's the force due to gravity. That 100 pounds is not a mass. I think the English unit of measure for mass is the slug. So the tension is the force due to gravity times the cosine of the angle that tension force makes with respect to the x-axis, which is 30 degrees. Right, because that tension has to overcome the force of gravity. And the second component, 100 times sine of 30 degrees. What is cosine of 30 degrees? Good thing you didn't have me for pre-calc, because you'd make me very sad. Well, I agree, 30 degrees is pi over 6 radians. But what's cosine of that? It's root 3 over 2. What is sine of 30 degrees? There's your tension vector. So the magnitude so instead of trying to do 50 squared, which isn't hard to do, there's a property of magnitudes. If you take the magnitude of a scalar multiple of a vector, it's the absolute value of the scalar times the magnitude of the vector. There's a 50 common. So it'll be 50 times the square root of 3, or yeah, 3, right? Root 3 squared plus 1 squared, which is 4.
Why would T1 equal T2 again?
Because they make the same angle.
T2 be 90 plus 60 degrees if we're trying to get the angle off the x-axis.
True, but the analysis is going to be the same. The only thing is because we're looking for magnitude, right? I'm not saying the vectors are equal. The magnitudes are equal. Right? You're right. The vectors wouldn't be equal. They would in a sense. Their components would be identical, just depending on a plus or a minus, right? Because they're going in all different directions. But the magnitudes themselves are equal because the angles are going to be equal. There's 100 pounds of tension in each chain, which seems to defy common sense. Welcome to physics. I have done the analysis. There's another way of solving this problem. Right, you do what he was just saying, set up the second tension vector, right? Then you do, what is it, Newton's second law? No, it's Newton's first law. It is, right? No, first law is object in motion stays in motion. So it's Newton's third law. Every action has an equal and opposite reaction. Force, the sum of the forces has to be 0. So if you're taking the magnitude of a scalar multiple of a vector, right? It's the absolute value of your scalar times the magnitude of the vector. Our tension is 50 times the vector root 3, 1, right? So just the absolute value of 50, then times the square root of root 3 squared plus 1 squared. And so I have done this analysis where I use Newton's third law. Right? The force of gravity has to equal the sum of the tensions. You'll get a system of equations, and if you solve for it, this is what you get. Right, the only difference is T2. This would be negative. Right, and then that would still be positive. And you still get their magnitudes are each 100 pounds. Are there any questions on vectors? Yes.
What's V? You know, what will we be using for that?
Well, where's my mouse? This here,
Yeah.
this V would be root 3 comma 1, right? Factor out the 50. Right, it's just to make the arithmetic easier to do in your head.
Oh, that's okay.
Right.
Do you prefer to do it that way?
Doesn't matter. In this case, you didn't have to because the angles were equal, which tells you their magnitudes are going to have to be equal. Right. If those angles weren't equal, then we would have to do some of the forces. Right. The force that I would have to do, the force due to gravity has to equal the sum of the two tensions. Anything else?